Welcome to my Commodore 64 Games Memories. This is where I look at old games and some of the technical details behind them. Let's get into it. Today we have Parallax Scrolling on the Commodore 64. Now the Commodore 64 only has one screen. It has a character-based screen, and that screen can also display bitmap data, but it's the same screen. The Commodore 64 also has 8 independent hardware sprites, which can move independently to the screen. However, the Commodore 64 only has one screen. The Commodore 64 has a horizontal screen scroll register, which is at D016 in hex, and the first 3 bits are the horizontal screen scroll position in terms of pixels. If we translate D016 into decimal, we get 53270. We can actually access this horizontal scroll register from BASIC. So I'm going to show you what that looks like, because we need to understand how the screen scrolls horizontally to be able to understand how we can get a character-based screen to scroll smoothly more than 8 pixels. So when we set the 53270 register with 0, you'll notice that the borders have been brought in, and as I set screen scroll position 1, 2, 3 and 4, the screen is shifting right by 1 pixel. And since it's 3 bits large, then we can have values in decimal from 0 to 7. If I try to put an 8 in there, then that will use the next bit along, which is too many bits, and actually bit 8 is used for the number of columns in the screen. But you can see if I move the cursor up here and then I go and press return on each of these lines from 0, and let's put another line here at the bottom for value 7 as well, the screen will scroll up, but the first poke will still be there, so that's okay. If I press return on each of these lines, you can see as I press return, the screen will scroll to the right by 1 pixel. At screen scroll position 1, 2, 3, and 4, and 5, and 6, and 7, you can see that the cursor on the left becomes more and more visible. Or rather, the P from the poke statement becomes more visible. If I add 8, then that says switch to 40 column mode, which is the default screen mode without any scrolling. And if I enable 40 column mode, in other words, the border shows 2 extra screen character columns, and then I change the horizontal scroll position, you can see on the left hand side here, when I'm using screen scroll position 7 plus the 8, which means to enable the wider borders, the screen has an extra 7 pixels, I think it is, on the left hand side, and if the cursor is moved off to the right hand side, then you can see that there is 1 extra pixel for the nearly obscured cursor on the right, but this column on the left is not alterable. It's just inserting extra blank data on the left hand side, empty pixels if you like, or background pixels. This is why many games, when they're horizontally scrolling, they bring in the borders to hide this extra empty space on the left hand side and to allow a character to be smoothly brought in. So if I move to scroll position 0 without the wider borders, by having the borders brought in by 2 characters, then there is a single pixel of the character, and actually the cursor on the right hand side can be obscured completely. With scroll position 7, and then if I move the character cursor to the left by 1, the cursor is completely obscured by the right border, but then if I bring the cursor 1 more position to the left, then you can see it there on the right hand side. You can try this yourself from BASIC, so you can see the screen extent which is actually visible, but at scroll position 7 the cursor is completely, the character column on the right hand side is completely obscured by the border, at scroll position 0, then we can actually see a small amount of the cursor coming in on the previous line on the right hand side. So this means that we can scroll the position smoothly in terms of horizontal steps using this hardware register for the pixels. So we have 8 different positions from 0 to 7 for the hardware pixel scroll for the horizontal one. But if we want to scroll more than 8 pixels, then we need to update the character position. So as we scroll the screen to the right, on the 7th pixel, when it loops back down to pixel position 0 for the horizontal scroll, we can advance a character 8 pixels to the right by jumping it 8 pixels to the right, so one whole character to the right. And then that will mean that the scrolling character will appear to be moving smoothly across the screen. I'll show you this effect by writing a small piece of machine code. Now, this small piece of machine code, which I'm using the inbuilt Vice monitor and assembler functionality, because it's only a small piece of code and it's going to be throwaway code, so we don't need to keep it. I'm going to be comparing the accumulator with the raster position, which is at D012, and then looking for the last raster position on the screen, which is at FF. And then I'm going to be pausing while the raster position is still FF. This is just like an interlock test, so that we know that we're only going to trigger this routine, this wait, once per screen. And I'm just incrementing the border color there so we know that we're hitting the correct screen position. But I'm just going to be incrementing D016, which is the horizontal screen scroll position, which is what we were just tweaking there in BASIC. And then going to be loading it, ANDing it with 7, and then storing it back again, just so that we have this range from 0 to 7. If it's not equal, in other words, if it's any number which is not equal to 0, then we'll just loop back to the start of the routine. So here we are, we'll loop back to the start of the routine if it's not equal, in other words, a number from, or not equal to 0, okay, because we got an AND there. But if it is equal to 0, we know that we've looped around from 7 back to 0 again. So we want to increment a character being displayed for the next character along, okay? So we'll do this very simply by clearing with a space character something indexed with y. It doesn't matter what y equals because we're going to be looping around anyway, and y can go from 0 to 255. We increment y, and then we'll use the ASCII character or PETSCII character for the star, which is 42 in decimal. Same as the ASCII code, actually, I think, for star in decimal. So 42 in decimal is 2A in hex. Whoops, slight typo. Let's put $, there we go. Okay. And then we'll store that in the next position. What this means is that every 8 times through this loop, when the scroll position equals 0, or when it transitions from 7 to 0, rather, then we will move a character across the screen at address 500 in hex, all the way up to 5FF in hex. This will be the second page in the screen memory, which will be about 5 or 6 lines down from the top of the screen. You'll notice that I'm assembling at 400 in hex. 400 in hex is the start of the default visible screen. That's why we've got what looks like gobbledygook or gibberish at the top of the screen. That is the code in memory. I'm going to be calling this code in memory now, and then you can see what the code does when it's actually running. So there's a little star there moving smoothly across the screen. I'm just going to remove that border color change because we can see that it's hitting the routine only once per frame. We don't need to have that distracting border color change going on in there anymore. So let's just change it so that we're incrementing a register value that doesn't matter, which is, at this point, it's one of the sprite horizontal position registers, but we don't care about that because there are no sprites visible. So if we warp for a little while to clear this whole second page of the screen, you can see now that the text in the background, which are the poke statements and the code and everything like that, don't move. They only horizontally pixel scroll between pixel scroll positions 0 to 7. But the asterisk, the star that you can see there, is moving smoothly. So I'm pausing the emulator here and I'm using the frame advance function, which is Alt and the plus key. You have to press Alt and pause first of all to pause it, and then you can press Alt and plus to advance a single frame. But anyway, you can see now that the star is smoothly scrolling all the way across the screen, and then it goes down to the next line in this screen page, and then it keeps on scrolling horizontally and smoothly across. That's because the star is being advanced horizontally for a character every 8 pixels horizontally scrolling. So when games do horizontal scrolling, that's what they do, but they do that for the whole screen. They shift the characters left or right every time they need to do this wraparound between the hardware registers. So this video is going to be looking at parallax scrolling on the Commodore 64, and we're going to be looking at the various different methods that were used in Commodore 64 games. The first game we're going to be looking at is Shadow of the Beast, and the introduction for Shadow of the Beast is actually very revealing. I'm going to be using the C64 debug GUI for most of these games because it allows us to see a wide variety of different information. So this game is really impressive, right? It has lots of levels of parallax scrolling, moving at independent speeds, but we want to see how this game actually accomplishes this. Now, if you remember the Amiga version, of course, the Amiga version uses, I think, its dual play field screen. It has more than one screen, and also it uses the copper chip. The copper chip allows register updates or hardware updates or memory updates to be done in precise timing with the raster position on the screen. The Commodore 64 doesn't have a copper chip, and it doesn't have a dual play field display mode either. In the VIC debug mode, and if I set the cursor position here, we can see that actually the game is using several different character sets. If I move the targeting cursor up and down, we can see how the character sets change. There's this character set used in the middle. Actually, the middle part where the mountains are behind the trunks for the trees, we can see that the character set view on the right hand side is alternating between two different character sets. In other words, the character set is not stationary, the character set is actually changing between two different values. And as we move down to the bottom here, we can see that there are some highlighted sprites for the wall, and we have a different character set being used for the bottom of the screen there, where we have the multiple different layers of the grass. Moving the targeting cursor up to the top, we can see that there are some sprites being used for the clouds, which have a priority behind the character-based trees, and then we have some more sprites being used for the layer of the clouds there too, and then we have the sprites down at the bottom of the wall. We have these expanded sprites in the middle there for the very large Shadow of the Beast scrolling text. So we have a lot of sprite multiplexing going on, which is where more than 8 sprites are visible on the screen at the same time. We can see that the horizontal X scroll register is being updated quite significantly, but at different rates depending on the horizontal raster line, especially for the grass here. So the characters for the grass are being scrolled at different rates. Now these alternating character sets in the background for the mountains are very interesting, as are the sprites being used here for the clouds. Notice the graphics for the clouds actually has two different clouds. It has clouds up at the top and it has clouds down at the bottom, and they're separated by a couple of blank pixel lines in the sprites here. And as the raster positions move down, it seems that the horizontal positions for the sprites are actually splitting these sprites horizontally as they get drawn vertically as well for those clouds. So the same sprites are being reused. Now, if I pause it on a good frame here, we can see that it's using character set F00. If I advance a few frames and then pause it again, and then advance and then pause, there we go, I've caught it now, and it's on character set C800. I locked the targeting cursor at that particular position on the screen so that we could sample the current register state, if you like. So if I click manually now on F00 and then manually click on C800 and then click back to F000, you'll see that the mountains scroll or shift a pixel to the left and to the right. This means that the two different character sets has these mountains shifted by a horizontal offset. This means it's using a pre-calculated character set to oppose the horizontal hardware scroll, which makes the mountains move at a different horizontal speed, apparent speed, to the foreground tree trunk characters. The tree trunk characters are also part of the same character screen, but because the two different character sets for the mountains are opposing the scroll, or the hardware scroll, then the mountains will appear to move slower. So this is a pre-calculated character set shift to create this parallax scroll effect, but it's only being used for the parallax scroll effect for the middle portion of this screen, which is for the tree trunks and the mountains. The rest of the screen is using a couple of different other effects to introduce the parallax scroll. So if I move the targeting cursor down, you can see it switches to the character set there, but the horizontal X scroll register is being moved as the targeting cursor moves down the screen. The X scroll register is being updated. We can see if I move the targeting cursor for each 8 pixels across and down the screen as well, you can see eventually where the register writes are being done there on the sampled disassembly for the CPU, the 6502, storing into the scroll register. So we can see that there are also register writes going into the sprite registers, but we can see the X scroll register being updated as now. If I click on the scroll button here and actually show the bad lines as well, this shows us quite comprehensively what's going on with the screen. So if I move the targeting cursor up and down now, you can see the whole screen shifting to reflect what the horizontal scroll register contents are, and you can see where it does that in terms of the character-based screen. So the X scroll register is updated quite significantly and quite often as it goes down, especially where the grass is. The top part of the screen is also using the hardware horizontal scroll register, but it doesn't update it as often. And that's because the clouds behind the leafy part of the tree, the crown of the trees, the clouds are actually sprites. So moving the targeting cursor down each line, we can see how the horizontal scroll register is updating different positions for each of the horizontal scrolling lines there. If I move it up and down, you can see how the screen uses the hardware scrolling left and right. Now the CPU still has to update the characters for the 8-pixel jumps for the background there. But that's what you have to do when you're scrolling the screen. To show what's going on here, I'm looking to put a breakpoint on every frame. This looks like the point at which the main line of the code waits for the interrupt. So I'm putting a breakpoint here on the RTS. And then this should, if I click the Run Continue button, yes, this should stop on every single breakpoint at that position in the code. So we can see here, notice the char set changes each frame, and notice how the hardware scroll is updated for the trunks of the trees. Every time I advance the frame by clicking the play button, notice how the trees scroll and then the background mountains don't scroll. And notice how the character set swaps between C800 now and F000. This char set swapping allows the mountains in the background to scroll at half the speed of the foreground scroll, which is the main screen scroll, which is the trunks of the trees in this instance. The expanded sprites then add an extra layer of parallax over the top of everything else. I really do like how this layer of clouds behind the tree canopy, the leafy part of the tree, uses sprite horizontal multiplexing, if you like. So the horizontal position of the sprites is actually updated halfway down the sprites. Now, although the vertical position of the sprites cannot be changed as the sprite is currently actively being drawn, the horizontal position can. And then we have this really very nice horizontal split in terms of the sprite positions for this layer of clouds here. So the same sprite is used twice but at two different X positions. This is really very efficient. It's only really possible because there is a very clear horizontal split between the two levels of parallax. And actually you could do it with sprites if you updated alternate sprites, for example, on one frame at a different Y position than the other. You could then have a merged layer of parallax where there is overlap between the sprites. You could do that too, but then it effectively reduces the horizontal resolution of the information that you can scroll using the sprite. So I think using it this way gives the illusion that you're actually updating quite a significant amount of data horizontally. You can see here that there are seven active sprites on a particular scan line here for the clouds. But I think it's a very effective way of adding parallax layers. In this case, it's mostly behind the character set layer. The character set layer is obviously the tree canopy. As I move the targeting cursor for the raster line here, left and right and up and down, you can see where it's starting to update the sprite X coordinates here. There it is in the code. Load A, store A D000, which is sprite 0 X position. D002 is the next sprite X position, and so on and so forth. So it's updating actually it's updating all 8 sprites. Look, 1, 2, 3, 4, 5, 6, 7, 8 stores into the relevant X position registers there. And then of course there's what looks like a self-modified store into D010, which is the MSBX value for all of the sprites, which is the most significant bit X position. That allows the sprites to go further off to the right, or to the left, but mostly off to the right. Anyway, so here we have a nice horizontal split for the sprites as well. So the sprite multiplexing is being used to add an extra couple of layers of parallax scroll. For the clouds and for the wall down at the bottom as well, the wall which scrolls in front of the grass there is actually extra sprites as well. So all in all, this screen, this title screen for Shadow of the Beast, uses pretty much nearly every single trick that I can think of to add parallax scrolling to this part of the game introduction screen here. Here I'm using the other debug view, which is the full screen view. Now I've zoomed everything out so we have the nice full screen here, but you can see as I move the mouse around, you can see where the sprites are being highlighted, but if I move the mouse around, you can see which character set is being used at a particular point on the screen. If I pause it now, I can actually count how many sprites are active, and I've kind of lost count, but it's what, 26, 27 sprites, maybe even more, probably 32. So there's quite a lot of sprites active on this view as well. I'm noting down the techniques used in each game. So Shadow of the Beast uses raster splits, the pre-scrolled character sets, sprites, and also a sprite split. The sprite split was used for the clouds. So we have 4 distinct techniques being used for Shadow of the Beast. Let's have a look at the next game in the list. I wanted to have a look at this excellent conversion, C64 Anabat, or rather Canabat, but for C64, or however the name is pronounced. But this has a rather lovely full screen scroll, and it then opens out into this full screen scroll with 3 levels of parallax. So we have the rather lovely muted background level of parallax, which is completely stationary, that grey background there with the crane in the background and the partially destroyed or constructed tower blocks. We have the middle layer, which is the main play area, and then occasionally we have this large, there we go, the large vertical column, and then of course we've got the large spaceship which comes along as well. The view here in the C64 debugger tells us pretty quickly what are sprites and what are characters. The sprites are of course surrounded by those red boxes. If we go to the Vic debug view here, we can see that the character set at this particular part of the game looks like it is static. In other words, the character set value on the right hand side is not updating, but then it actually did change. There we go. Okay, so now we're in the, the game over part of the screen flips to a different character set for the message, which is not unexpected. If I put the targeting cursor at this point in the screen, we can already see, look, the character set is actually changing. And the character set is changing between what looks like at least 4 different character sets for that particular part of the screen there. And that's not a surprise, right? It already looks very much like that this game is using a pre-computed character set to offset the shift for the background to counteract the horizontal pixel scroll, the hardware pixel scroll, for the middle or foreground, if you like. We can see that it's all characters, and we can see that there are some sprites being used there for the game over screen, of course. Flipping to the full screen debug view. The birds are sprites, of course. The boxes are also sprites. The broken, or the window that breaks, blink, turns into a whole bunch of sprites, as you would kind of normally expect. We can see in the char set view there, actually, we can see the character set rapidly flicking between different character sets, and of course as the scroll speeds up, the character set doesn't need to update as much, kind of, depending on if the character set Well, if the scroll is going so fast that the character set doesn't need to be swapped to offset the horizontal pixel scroll from 0 to 7, then of course it doesn't need to swap it. I'm just trying to catch the screen display when the large vertical column of what looks like sprites is coming on the screen. And yes, as we can see, as I move the targeting cursor up and down to look at sprites active during each raster line, then we can clearly see that the same sprite is being reused. It's just that the vertical position of the same identical sprite is being updated. So if I change the character set, which is visible now by clicking on the right hand side, you can see how the background for the screen, the grey background for the screen scrolls as I change the character set. This definitely tells us that we're using or the game is using a pre-calculated character set to completely offset the hardware scroll. So the hardware scroll goes from 0 to 2 to 4 to 6 in terms of the horizontal pixel scroll position because it's multicolor, and then the multicolor background is scrolled in the opposite direction between 0, 2, 4 and 6 pixels. So that's what keeps the background completely stationary. And in this game, compared to Shadow of the Beast, where Shadow of the Beast had a half-speed scrolling background for the mountains, so it only needed 2 character sets, this one needs 4 character sets to completely offset the hardware pixel level scroll for the whole character screen. These 4 character sets, which are needed to completely offset the horizontal hardware pixel scroll, these 4 character sets don't have to be in the same bank. I mean, the character sets could be split over a couple of banks, for example. Putting all of the character sets in one bank does significantly reduce the number of sprite frames, individual sprite frames, that can be stored in a screen bank, of course. But it's mostly how you want to decide how to update your screens and your graphics usage in terms of the game. If we use this full screen debug view again, let's move all of these windows off to the side. The palette can just stay down there in the border. Note what goes on in the character set. So as I move that's odd, it's actually not showing the information for the position in the screen for that particular character set. Why is it not updating the character set view? One moment. Yes, if you look on the right hand side, I locked the character set with the red overlay there. Now I can move around and I can actually see the different character sets that are being used. Yes, I have to remember in C64 Debug GUI to unlock which character set is being shown. If I lock the character set, then it doesn't show the screen character set correctly in this view. And then if I click on the scroll, then of course the displayed character set is not going to be, for the background parallax, it's not going to be offset the horizontal scroll, and then that of course means that it judders. If I unlock the character set, then the background parallax layer with the scroll enabled will show a nice stationary background parallax layer. So there we go, that's a little feature, if you like, of the C64 Debug GUI for this particular version anyway, is that if you overwrite the character set, then it's not going to be showing the character set. Now, of course, that the correct character set is shown in the top left-hand corner, you can see as the screen scrolls, the character set is swapped to the relevant scrolled character set for the background parallax layer. And of course the character set changes depending on where I've got my mouse pointer as well. So my mouse pointer shows the character set that is currently at that position on the screen. So the character set in the top left, you can see the pre-scrolled, pre-calculated characters there, and those characters are the characters that are used for the background parallax layer. I like how the crumbling building falls down there. That was great. This really is a lovely looking game, and it's very simple. You just have to jump at the right position. I wonder if sometimes you have to slow yourself down again to avoid getting too fast, so that you can actually make some of the jumps later on. My reactions are not that good, so I'm not that particularly good at the game. And it's also, again, harder in the C64 debug GUI because the video frame update is not as fast as a normal version of Vice, for example. But it is a lovely looking game, isn't it? It's fantastic. The large spaceship that comes along every now and again is just a great big sprite grid. So let's update this spreadsheet with the various techniques that we discovered while looking at that game in the C64 debug GUI. So we have sprites being used for parallax layers. We have the pre-scrolled character set. And I think that's about it. So this was a game demo that was floating around. And look at how the Hawkeye 2 logo uses sprites in the foreground to obscure the background, which is scrolling characters. That's quite a lovely effect, isn't it? It's quite understated. But the main game effect that I wanted to have a look at was how this full screen, what looks like a full screen color scroll, is using, as you can see on the right hand side there in the character set view, the character set indicator changes when the screen scrolls, and it's changing between 4 different character sets again. So we have the sprites in the foreground, of course, as you would normally expect, but we have this rather lovely example of a screen. So don't look at the debug view, because the debug view is a little bit jittery and juddery. Look at the top right hand corner of the screen there, and you can see how smooth it looks. If I turn off in the debug view the scroll, the pixel level scroll, you can see how the background parallax layer switches to the different character set, which offsets the scroll, but the scroll is not visible. But now I've enabled the scroll, you can see there how the foreground layer changes its scroll position depending on the scroll register. So the background parallax layer does use 4 character sets, but it updates which character set is visible at a different speed to the foreground character set scroll speed. And because each of the 4 pre-computed character sets is offsetting the horizontal scroll at a different rate to the main hardware scroll, then we have this rather lovely parallax effect where the background scrolls at a slower rate but isn't completely stationary compared to the foreground. And of course we have all of these extra sprites too. Now, if this game demo actually went into a full game, then I expect some of the sprites would have actually been used for an extra foreground parallax scroll layer as well. In some certain circumstances that would have been possible, perhaps like bushes or trees or other foreground elements like large pieces of wall or something like that, because this is quite an accomplished multiplexer. So anyway, Hawkeye 2 demo, we can already note down the techniques used. So we have the pre-scrolled character set, of course, and I think the cat agrees with me that there is only a pre-scrolled character set here. So in Hawkeye 1, the original version, we can already see that 4 character sets are being used during the horizontal scrolling portion of this part of the display, which is the main game area. If we move to the right there, then we could start to see the completely static background, which is used for the background parallax scroll layer. Yes, I know. The cat is also agreeing that that's what we can see. So if I again switch manually between the 4 different character sets on the right hand side there, you can see the background parallax scroll layer updating for the 4 different pixel scroll, multicolor pixel scroll positions for the background character set that's being used there. So again, we have Hawkeye also using a pre-scrolled character set, or a pre-calculated scrolled character set. I think my cat is wondering what on earth I'm doing. Who are you talking to, she's saying. Well, I'm having a presentation, my little cat. Anyway, so let's have a look at the next game. There isn't any horizontally scrolling raster updates or anything else like that going on in this game. It's just using a pre-scroll character set. Let's have a look at Firebird now, and if you look in the top right hand corner, that's the actual visible portion, but if I move the targeting cursor up and down, you can just see how many multiplex sprites are being used. Some of them are horizontally expanded for the tree, for the leafy part of the tree, that's sprites. But we can also see that there's quite a lot of color changes going on. Now the color changes, if it's on a proper CRT monitor rather than, you know, like an emulated display like it is here, then the rapid color changes introduces an effect where the monitor, where the CRT display rather, will show in between colors, because the colors are changing rapidly, so that introduces, you know, by persistence of vision and the phosphor persistence of the CRT display, it shows in between colors. That's a good method of showing extra colors on the Commodore 64 here, but if I move the targeting cursor up and down, it shows just how many sprites are being used. So we can already see that it's just basically using horizontal raster splits for the scroll positions, but it's also using multiplexed sprites. This isn't the only game that used that kind of effect for color, alternate color or flashing color in between color displays. Rather, quite a few games used it. It wasn't an extremely common technique, but you know, quite a few shooter games and stuff like that used that technique to have nice metallic colors, for example, or shiny colors. But this game very effectively uses quite a lot of sprite multiplexing to get the extra layer of parallax scrolling. Of course, the rest of the characters, for the background, the character set doesn't really change, right? If I scroll up and down here, you can see that the character set is not changing. It's using a static character set. It's just using a different horizontal X scroll hardware register update, and it's also, of course, updating the characters at a different rate depending on the parallax scrolling layer. The flickering colors as well, you can see quite clearly on the moon, on that top right hand corner there, the moon and the blimp, which is very Shadow of the Beast-ish, right? But basically it's, what is it? I think it's between grey and orange, or maybe brown. That produces an in-between color on a decent CRT display. So yeah, not the only, not an unusual technique. It has been used in other games way back in the day. So flickering, alternating colors is nothing really new. It's nothing really special. Lots of games use that kind of graphical technique, and also dithering as well. So if you combine dithering with alternating color updates as well, then this introduces even more extended colors on the Commodore 64, if you like. But the thing about this game demo, if you like, is that I was really impressed with how the tree uses a huge amount of multiplexed sprites, especially with horizontal expansion. And it hides the horizontal expansion for the sprite really well as well. You can see here in the full screen debug view the huge, great big sprite sheet that's used there for the tree. but it's also updating using sprites for the moon and the blimp, for example, and the player, or the bird, and what is it? The butterfly. I think it's a butterfly. And there's an extra little layer as well for the bare brown orange tree in the background as well. So anyway, I think we can say safely for Firebird that it's using raster splits and also using multiplexed sprites for parallax scrolling layers. So that was Firebird. A really good implementation of parallax scrolling with expanded color resolution as well. It doesn't look so great in the emulated view, of course, with the alternating colors, but that's because the emulated view doesn't have the CRT persistence for its pixels and the categories. Next game. Here's a hidden gem, which is Lost Robot 2. If you have a look at the X scroll hardware register there, as I move the tracking cursor or targeting cursor up and down, you can see the different X scroll position which is being updated for the different raster Y positions there. So as the game has different parallax levels, especially for the background character set, it's using a raster based horizontal pixel scroll position there. Now that was the title screen portion of the game. Let's go to the actual main game portion of the game as well. On the left hand side we have a massive sprite grid there for the foreground tree for the parallax level during the game, and that quickly scrolls off, and then we get a whole bunch of enemy sprites come on the screen. And the sprite sheet actually, or the sprite grid, comes scrolling onto the right hand side again for that foreground layer of the tree. So I think we could say that it also uses sprites for the parallax layer, and that's during the game rather than the title screen. So that was Lost Robot 2. From 1987 we have Army Moves. Now you'll notice that the clouds at the top move at a different speed compared to the bridge graphics and the clouds at the bottom of the screen. So I think we can safely say here that the X scroll position is updated at a different rate. Oops, I think I had the, I did, didn't I? I had turbo warp mode on. There we go. Now we can see it a lot clearer. Now the scrolling speed is a lot slower rather than warping ahead at 10 billion speed or whatever it was. Right, so we have the character layer in the bottom having a different horizontal X scroll position compared to the character screen up at the top, which is where the clouds are. So even back in, like 1987, games were using the hardware scroll to have a nice parallax effect with their character-based screens, which is interesting, right? I mean, games even way back in that era were using these kind of techniques of different hardware scroll values for their game screen update. So let's update this spreadsheet with that information that we have. So we have a raster based horizontal pixel scroll for Army Moves. Also from back in the day was Morpheus. Now Morpheus was one of my favorite games, and it also has a rather nice parallax scroll for this launching effect here and also the docking effect. I think it was three levels of scroll for the character-based scroll, but then it also has the mothership on top of that, which in this version is green, and that was on the left-hand side. Let's see if I can show that again by docking. Docking with this particular version of C64 Debug GUI is difficult sometimes because the Alt key seems to block for the joystick control. It's not great. I wish it was possible to change that in debug view, but there we go. The characters come in and they fade in, and then we have that multiple levels of scroll. So let's have a look at the character set. In the full screen debug view here, it will also highlight where the sprites are for the foreground level, which is the mothership on the left there. You can see the sprite grid there. But you can see the characters in the character set are updating as they fade in and fade out, and also show that parallax scroll. I will link the Morpheus video that I did previously in the description for this video, and that goes into a lot more detail about how the character set is computed at runtime. But I think we could say that it's an animated character set. Animated in this sense meaning that it's animated by the code rather than being a pre-scrolled character set which offsets a particular screen position, like in Hawkeye and Shadow of the Beast. So we have the animated character set and also a sprite-based layer for the mothership, which scrolls off. This is from a game that I made a long time ago called Tusari. In this disc version, this is a bonus level after level 2, I think it is, or something like that. You'll notice when I move up and down, sections of the screen will actually move apart from each other and scroll at different horizontal rates. The mountains are stationary. The middle portion, the green portion there, has animated character sets scrolling at a different rate to the main character screen scroll. The debug view here actually doesn't update properly because it's using a technique to expand the differences between the different horizontal portions of the screen. It's expanding it using a flexible vertical difference between the character sets. Actually, the debug view doesn't show the screen display at all. But if you look up in the top right-hand corner, you can see that there are black lines being introduced between the different versions. And if I move up and down, the different layers of the screen contract and expand depending on the vertical position of the player character on the screen. So, and you can see the bad lines, which are these horizontal lines in the debug view. They get wider and narrower as the screen expands. Also, it's using horizontal hardware scroll differences depending on the raster line as it goes down the screen to introduce a different horizontal scroll speed. But basically these lines here, if we have a look at the code, as I move up and down between each of the rasters, we can see that it's doing a raster test for a particular position. And then if I move over, there we go, there's the comparison with D012 in the code view there on the left hand side. That's D012, which is the raster position. But then it is updating the D011 register there, which is highlighted in the code view right now on the left hand side. Now that update of the D011 register is important. This is the Y scroll register. And if you update this Y scroll register with the current raster position, ANDed with 7, then what this causes is that it causes the VIC chip to not display a new character row at the position that it's expecting. It basically shifts the character row down and makes the VIC open a blank area on the screen. So that actually pushes the subsequent character rows down by the number of pixels that you're doing this particular register and effect update for, which is why the bad lines are expanding and contracting. It's why the different horizontal portions of the screen are expanding away from each other at different rates, because I'm telling it to push the scroll for the screen or push the character screen update further down the screen. So this effect is an FLD effect. It was used in demos a lot, but as far as I know, Tusari is one of the original games which used this FLD scrolling effect for vertical parallax scrolling. So this game uses a couple of techniques. It uses the horizontal raster scroll position. It uses an animated character set for the see-through parts, if you like, for the green area of the screen in the middle there, but it also uses FLD, which is for the vertical parallax scrolling effect. So we'll put that information down into the spreadsheet, and we'll go on to the next game. When Zeta Wing 2 came out, it was a real treat because it's a lovely vertical scroller with a very accomplished sprite multiplexer, but also it has rather lovely parallax scrolling in the vertical direction this time. With this full screen debug view, we can exactly see where the multiplexed sprites are. But also we can see in the top left hand corner here that the character set is being updated, and the character set is being updated to counteract the vertical scroll. Now, depending on the portion in the level, actually the characters are being updated with different vertical scrolls, and actually the characters get updated depending on where you are in the level as well. So let's get back to that point in the level. So watch there, and there it is. There's the animated characters for the background wavy lines there, and these background wavy lines behind the clouds really do look lovely, don't they? And you can see how many animated characters there are there. It's probably like 10 or 12 of them. So now notice how these characters are being animated differently to the start of the level, and how that particular portion of the middle part of the level there, where it goes all, where you can see the below level, and here is another example coming up here, how the different speeds for the vertical scrolling of those characters, how they're animated, makes it look like we have depth to that particular portion of the level. And then this opens up like this, and it really shows to great effect the vertical parallax scrolling using animated characters there. That's a really lovely use of that effect there. So I think we can safely say that Zeta Wing 2 is using animated character sets. It's not pre-scrolled, it's scrolled using software or copying from somewhere else, but basically I think we can safely say that Zeta Wing 2 is using animated character sets for its parallax scroll level there. And a rather lovely example of it too, I think. Talking about vertical scrolling parallax has reminded me that in the SEUCK Redux code I added the ability to have multicolor character or block based parallax scrolling as well. So there are two SEUCK data files here. This is the foreground layer. Now the background character layer there has a regular array of characters, and you can see that the first chunk of characters up at the beginning of the character set are basically reserved with those vertical line patterns there. Now it's important why the first block of characters there is reserved, because the next data file actually shows why. Now those characters get animated in code. In other words, the code will merge what are effectively these two blocks. You'll notice that the first block has two different colors used. It has white and gray, and then it has dark gray used for the other character block. So the characters used for these two character blocks will get merged in code and then animated and software updated into the character set used for the foreground scrolling layer. And I'll show you what that looks like in terms of code when it's running. If I go to my SEUCK Redux code here and then build it and then run it with the relevant switches enabled, you can see the vertical scrolling parallax effect there. So we have three levels of parallax. We have the hardware vertical scrolled parallax layer there, and then we have the two levels in the background character block there as well. So I'm going to run it in the C64 debug GUI as well, so you can see what it looks like. Let's not have warp mode on. There we go. So this is the title screen, and there you go. You can see it in a lot more detail. Where has the character set debug window gone? It's disappeared. There it is. Okie dokie. And you can see how the character set is being software updated so that it's using animated characters for that parallax scrolling level. And actually it looks really good, right? I mean, we've got 3 different distinct layers there. We can see where the sprites are being used in the border as well, but it's a very effective way of having multiple parallax scrolling level layers, especially if you can afford the CPU time to do all of this masked pixel update. So the background parallax scrolling layers are actually using proper bitwise masking as well. There's no EOR glitches or anything like that going on. So I think we can safely say that in the SEUCK Redux code, the vertical parallax scrolling there is of course using animated character sets, a lot like Zeta Wing 2. Last but certainly not least is Parallax, and it has parallax scrolling. It has multi-directional parallax scrolling, so the background there, as you can see, scrolls at a different speed to the foreground. Now that is accomplished by, of course, if you look in the character set view up in the top left hand corner, it's using animated character sets to update those animated 2x2 tiles that are used in the background. 2x2 character tiles, so that's 4 characters in total, right? The characters in the background there, you can see they are software animated characters, which basically offset their scroll slightly opposite to the main screen hardware scroll value, but not completely. That's why they scroll at apparent half speed compared to the foreground. So I think that's going to be the last game in this video. The video is already quite long, and it's gone through and looked at various different games on how they implement parallax scrolling on the Commodore 64. I think we need to update the spreadsheet, right? So updating the spreadsheet. Let's have a look at the final numbers. I think Parallax only uses an animated character set. So if we have a look from this sample of games, we can see that the most common effect for parallax scrolling is the use of raster-based horizontal scrolling offsets and also sprites, which was quite a surprise. Animated character sets are used relatively often. Pre-scrolled character sets are used very often, but that's probably because of the sample of games that I looked at. I didn't look at all the games, obviously, because that would take ages. Sprite splitting is very unusual for games, and with the sprite splitting used in Shadow of the Beast for the level of, oh gosh, I'm sorry, the cat's meowing a lot, for the clouds layer in the background. And FLD is obviously the also a very unusual way of implementing vertical parallax scrolling from the sample of games that I looked at. So if you like these kind of retro Commodore 64 games memories, especially technical deep dives into these games, then please do consider liking or subscribing to my channel. And if you really like the work that I do, then a super thanks is very much appreciated. Thank you very much for watching. Take care, have a great day or evening or night wherever you are. And the cat says goodbye as well, don't you, cat?